this example, in this question, we're going to use the second derivative test to find the local extrema of this function right here, 1 over cosine x plus 2. So remember, to find the local extrema using the second derivative test, we need to, let's write down what we're going to do here. First thing is we're going to find the critical points. And after we find the critical points, we're going to plug those critical points into the second derivative. So the second derivative. Okay, so to do that, well, we need to find both things. We need to find the critical points, and we need to find the second derivative. So let's start off with the first derivative. Let's see here. So the first derivative, we can either use the quotient rule, or this guy, we can bring it up on top as cosine of x plus 2 to the negative 1, and use the chain rule. So let's do that. So if we use the chain rule on that guy, we would get negative cosine of x plus 2 to the negative 2 times the derivative of the inside, which is going to be sine of x. It's actually negative sine of x, and so that makes this guy into a positive. Okay, so if we simplify this a little bit, we're going to get sine of x over cosine of x plus 2 squared. Okay, and then we need to find the critical points. So the critical points are all the points where the derivative does not exist. So in other words, in this case, where the denominator equals to 0 and where the derivative is equal to 0. So when the numerator is equal to 0. Okay, so first notice that this guy is never, cosine x plus 2 could never equal 0. If you try to solve it, you'll realize that it doesn't work, because remember, cosine is always between negative 1 and 1. So we don't have to worry about the bottom. So if you multiply both sides by cosine x plus 2 squared, then what you get is that you're solving sine of x. Sorry, let me erase this guy. You get sine of x equal to 0. Okay. So then our critical points become everywhere where sine of x is equal to 0. So we know sine of x is equal to 0 at 0, also at pi, and then this keeps going on forever for all multiples of pi. So I'm just going to write k pi, where k is any integer, so a positive number or a negative number. So those are the critical points. Now obviously I can't plug all of those into my second derivative, but since we're not given an interval, normally with trig functions we're given an interval, but this case it's open-ended, so we have to write all of them down. Okay, so that's our first step. So we did that. Then we're going to plug in those critical points into the second derivative. So let's actually find the second derivative. Okay, I'm going to do it right here. So to find the second derivative, now I need to use the quotient rule. So I'm going to have derivative of the top, cosine, times the bottom, which is cosine x plus 2 squared, minus, top leave it alone, times the derivative of the bottom, which is, by the chain rule, 2 cosine of x plus 2 to the 1. Now, of course, you don't have to write it, so you can if you want to, but I'm not going to. And then times the derivative of the inside, which is negative sine of x. And then all of this is going to be over cosine x plus 2 squared, or in other words, to the 4th. Okay, now let's simplify this a little bit. Notice that here I have a cosine, oh, that's no good. Aha, see that? Expert undo. Okay, so check out this guy right here and this one. So there's a like term here. So I can factor this guy out. And this is going to help me because I'm going to be able to cancel it out with one of the ones on the bottom. Okay. So I've got that guy. So I factored out that guy. So then inside what I have is cosine of x. And then here, now let's try to do, oh wait, cosine x times cosine x plus 2, right? Because I have 2 here, so sorry, my red went over the 2. And then here I have 2, so this one I factored out, so I no longer have to worry about that one. And then negative sine times 2 times negative sine, that's going to be plus 2 sine squared x. All over cosine x plus 2 to the 4th. Okay. So then I can get rid of this guy with one of these, and this one becomes a third. Okay, so now I think I'm going to leave it like this. We could do a little bit more, I guess. We could do a little bit more. Let's distribute this guy. If I distribute this guy, I'll get cosine squared x plus 2 cosine x. So let's do that. Cosine squared x plus 2 cosine x. Okay, and then plus 2 sine squared. Now, I'm going to write this as plus sine squared x plus sine squared x. And all of this is going to be over cosine x plus 2 to the 3rd. Now notice that the reason why I did that is because if you look at this guy, sine squared plus, oh my gosh, that was terrible, cosine squared, those two put together equal to 1. So then what I have is 1 plus 2 cosine x plus sine squared x. over cosine x plus 2 cubed. Okay, so now let's rewrite this. I need to get a new sheet. So now what I want to do is plug, now that I have my second derivative here, I want to plug in my critical points, which were 0 and pi and 2 pi, into this guy, the second derivative. And remember, what I care about is what the sign is. So here I'm going to have sine squared of 0 plus 1 plus 2 cosine of 0. Now on the bottom, notice that no matter what number you plug in here, since cosine is always between -1 and 1, you're going to add 2 to it. So this means that the denominator is always going to be positive. So what this means is that I'm not going to worry about the denominator at all. I'm just going to focus on the numerator, and that'll save me some work. Okay, so sine squared of 0 is 0 plus 1, and then cosine of 0 is 0, so plus 2. So this guy is positive, which means that at this critical point, let me draw a picture. So you have a critical point, and then at this critical point, actually let me draw it right here, it's concave up. So that means you have a flat spot, and it's concave up, which means that this would have to be a, so at 0, there's a local minimum. Okay, and then if we plug in pi, so we would have sine squared of pi plus 1 plus 2 cosine of pi. Now, cosine of pi is -1. So this time I have 1 minus 2, so this guy is going to be negative, which basically means that you have a critical point, and then right there at the critical point it's concave down, which means that at pi there's going to be a local maximum. And then to find the y value, remember you plug these values into the original function. And that's it.